Welcome to my video on balance, also known as equilibrium. So again, we're going to be looking in the ear. This time we're going to be focusing on the semicircular canals and the vestibule. So we're going to be talking about two different types of equilibrium. So the first one is rotational equilibrium, which can also be called dynamic or horizontal equilibrium. It happens in the semicircular canals and it detects head or body rotation, so spinning in circles. Okay, this time we have something called a cupula, which is at the base of our semicircular canals, and little hair cells within them, when they bend, because the fluid within the semicircular canals are pushing against it, that's going to tell our brain that we've been moving or spinning. Okay, so that is everything we need to know about rotational equilibrium. Moving on to the second one, which is gravitational equilibrium, which can also be called vertical or linear or static. Okay, it's basically when we just move our head from side to side. Okay, up and down. Okay, forward and backwards. And it happens in the vestibule. This time we have something called otoliths, which are little crystals on top of an otolith membrane, which is kind of like jello. And every time gravity pulls your head to one side, these otoliths are going to be weighed down to the one side and it's going to pull these hair cells to the one side. Again, they're going to bend and it's going to send an impulse to our brain saying that we've moved our head. So in your guys' notes, you have 4 different diagrams. Okay, so it points to the semicircular canals and the vestibule. And we're going to go through the first one, woman standing still. Okay, this is going to be rotational equilibrium found in the semicircular canals. So we have a couple different things we're going to draw. So first of all, we're going to draw kind of the basis. So a membrane that has a whole bunch of cells on the bottom of it. Okay, these circles just represent the nuclei in each one. So we have this. Okay, we have something called the cupula, which is like basically like a jelly sac. Okay, almost looks like the tip of your thumb. And inside the cupula, you have hair cells. Okay, these hair cells are connected to the vestibular nerve, which sends information to our brain about our balance and posture. So when we're standing still, the cupula is upright, the hair cells are straight. When we're turning, the cupula is going to change. So if we're turning this direction, the fluid that fills our semicircular canals is going to push the cupula to the side, which causes the hair cells inside the cupula to bend. As soon as they bend, that's going to send an action potential on the vestibular nerve, which attaches to our brain, and then we know that we're moving. So that is our rotational equilibrium, okay, turning in circles, what's happening inside our semicircular canals. So I'm going to show you guys another diagram, just in case you're unsure about what I'm trying to draw. So here we have our semicircular canals. At the base of them, you have little cupulas. So these cupulas look like little thumbs. Okay, they have little hair cells inside of them. When the fluid inside the semicircular canals moves, okay, because we're spinning, it's going to push these cupulas to the one side, which is going to bend our little hair cells. So that is kind of what I was drawing on the previous diagrams. So now moving forward, you have 2 more diagrams. This time we're going to be focusing on gravitational equilibrium. So this is kind of the basis of the diagram. Again, a whole bunch of cells attached to nerves, and we have hair cells again. This time our hair cells are embedded in basically a sheet of jello, which is called the otolith membrane. Okay, on top of the otolith membrane, you have otoliths, which are like crystals, and embedded in that again are hair cells. So anytime I move my head from down to the front, backwards, side to side, okay, this time I'm moving my head down, gravity's going to pull the otoliths to the one side because they're weighted. It's going to cause the hair cells to go to the one side. And as soon as that happens, again, it's going to start an action potential to the vestibular nerve, and it's going to send an impulse to our brain. Our brain is going to interpret that as, oh, our head is tilted. We should probably tilt it back upright. So again, I'm going to show you guys a diagram of this just to make sure you understand what I was trying to draw. So this is what it looks like in real life. Okay, so again, otoliths, which are just a whole bunch of little crystals inside of our inner ear, inside the vestibule. Okay, anytime we move, it's going to pull those otoliths to the one side because gravity is pulling it, and we see the hair cells that are embedded within our otolithic membrane, okay, are going to bend, starting an impulse, okay, sending that information to our brain. So that is basically how equilibrium works. Okay, of course, you guys need to know the diagrams for a drawing quiz. Okay, if you have any questions about how this process works, please ask. If not, I will see you all tomorrow. Have a wonderful evening and good night.